Hello, welcome. I'm going to talk about graphs. Graphs. Mainly, I'm going to talk about the graphs of distance, of displacement, of speed, and of velocity against time. So we'll see the difference in a moment, at least for simple examples. So let me start with a distance time graph. Right, let me think of this example. Let's say that's me. Okay, that's me. And one morning I decided to take a walk. And I decided to walk in that direction. Maybe that's towards the east, and I like to see more of the sun, so I walk in that direction. And suppose that I walk some distance every second. Let's make it simple. Let's say in each second I walk 1 meter. So that's manageable, I think. Okay, so and after another second I walked another meter, and so on, and you can tell from here that after some time, maybe after 10 seconds, from the start, I would have walked a total of 10 meters. Okay, so that's simple enough. Now, how would I plot a graph of, say, the distance time graph in this case? I think that's might be quite obvious to you, too obvious in fact. Let me write down distance here and time here. Now it would be convenient to use some short form actually. So let me use D for distance. Actually, let me just leave the distance. Right, okay. So after 10 seconds, over 10 seconds, I want to plot this graph. So in the beginning, I am at 0 distance when I first started. So my point would be that's 0 time and 0 distance, and the time is in seconds, distance is in meter. And after 1 second, I have walked 1 meter. So I put a point on my graph here. Now after another second, that means after a total of 2 seconds, I would have walked a total of 2 meters. So I have another point there. And it goes on, and as you can see, after 10 seconds, let's say, my graph is not really to scale, but you get the idea. After 10 seconds, I would have walked 10 meters. 10 meters in total. So that's what my graph would look like. It looks like a straight line. If I join the points, that's my graph. Okay. Now I'm going to do something different. I'm going to say, right, I decide that walking towards the sun is a bit warm, and it's not very interesting. All I see is houses, so I decide to turn back and head in the opposite direction. Maybe I can find some more trees and parks on that other side of my house. So I decided to turn back, and I continue walking at the same speed, so that each second I walk 1 meter and so on, and then After some time, I pass by my house. After 10 seconds, another 10 seconds, I pass by my house, and I carry on to look for my trees and parks. Okay, so if I continue with plotting this graph, I would find that after another 10 seconds, I would have walked another 10 meters. Even though it's back to my own house, I would have walked another 10 meters. So after another 10 seconds, it would be 20 seconds altogether from when I started walking, and I would have walked another 10 meters. So that makes it a total of 20 meters, a total distance of 20 meters that I would have walked. So let's say that's 20, and if I put a point there, my graph would look like this. It would just keep on increasing in a straight line, since I'm walking at I walk by the same distance every second. So that's a very simple distance time graph. Now you might think that's a bit boring, I know all about graphs. Well, okay, wait till you see the next one. You might find that really strange if you have not seen it before. So here we go. Now in the next graph, I'm going to do something different. I'm not going to plot the distance time graph. I'm going to plot the displacement time graph. Displacement is also measured in meters, and time is still measured in seconds. Okay, so those are the axes that I need. Now what do? Let's see. Okay, let's start. So displacement, right? Displacement. So I'm going to start from the beginning again. Start from there when I was at rest, and when I was at rest, well, I mean, as in at the beginning when time is 0 seconds, my displacement is 0 seconds. So I'm here at the start, just like before, and after every second, my displacement changes by 1 meter. Okay, my displacement changes by 1 meter. 1 meter. Now at this point, after 1 second, changes by 1 meter. Let me mention something very important and always overlooked, always forgotten, which is that displacement has direction. And for motion along a straight line, we should always choose one of the direction to be positive. So in this case, I can choose left or right as positive. Either way is perfectly fine. Now I'm going to choose the right to be positive, so that means my left is a negative direction, and that's my starting position. So after 1 second, my displacement has changed by 1 meter, and after 10 seconds, my displacement would have changed by 10 meters to the right. Okay, so that means that to the right is positive, so my displacement would go all the way up to, would change all the way to 10 meters per second, plus 10 meters per second, and that's what happened after, I got a point there, after 10 seconds. Now you might say, that looks exactly the same as this, so what's the difference? Why am I doing this? Okay, fine, it's true, they're the same, but now let's see what happened next. Now I decide to turn back. Now after 1 second, I would have walked 1 meter. Now this time, what is my displacement? Well, if you recall from my earlier video on displacement, the displacement when I'm here would be the direct we're talking about displacement from the start. Alright, just to be clear, from the start, and not the displacement from where I was in the last second. So the displacement from the start when I turn back and walk by 1 meter would be we could get that by drawing a straight line from the beginning to my current position. Now if I look at that was 10 meters, and then I turn back and walk for 1 meter, so this distance must be 9 meters. So my displacement at this point in time is 9 meters in a positive direction. So I remember that I was at 10 meters, so now I'm at 9 meters. So my displacement, or the magnitude of my displacement, has decreased. It's decreased to 9 meters, and that happened after another second, which is the 11th second. So that's that. So my graph has turned back. Now you start seeing the difference from the distance time graph. Okay. And let's see what happens if I continue walking. If I continue walking, you might imagine that my displacement from the start position should decrease, alright, as I walk, and eventually when I walk after another 10 seconds, I'll be back at my starting position, and my displacement there would be zero. So that's what happens. That's what happens. So the graph would go all the way down to 0 by the time it is 20 seconds from my starting time. So if you look at this graph and if you look at this graph, they are completely different. That's just a straight line, and that is a triangle. Okay. Now if you think this is odd, wait till you see the next graph, or rather the next two graphs. So let me clear this part off. Okay, so let's quickly try to sketch the next graph, and that would be the speed time graph. The speed time graph, and speed, as you know, is in meters per second. Time, in this case, is in second. What is the speed? Right, let's start from the beginning again. In 1 second, I walked 1 meter, so my speed would be 1 meter per second. Okay, let me put a point there, 1 meter per second. I've already written down the units, so it's just write 1 there. So it remains 1 meter per second all the way for the first 10 seconds. So you know, like the first second, 1 second, 2 seconds, and so on, it's all 10 meters per second all the way until 10 seconds. Oh, that's second, by the way. That's the unit. Okay, so the graph would therefore look like this. So I'm just walking at the same speed for 10 seconds. Okay, right? That's simple enough, not very interesting. Now, and now I decide to turn back. If you remember, I decided to turn back then, and I continue to walk for 1 meter every second. So it's still the same speed. Right? And continue walking until I come back, until I reach my house, and I just keep going. So what is my speed then after another second? That means on the 11th second, right? I was still walking at 1 meter every second, so it's still 1 meter per second, and I'm just going to keep up the same pace, so all the way until 20 seconds. So it's just going to be like that. My graph, it's just going to be a horizontal line at 1 meter per second all the time. Okay, right, indeed, that's not very interesting. But now let's look at the next graph. The next graph that I want to draw is the velocity time graph. Velocity time graph. It's in meters per second, and time is in seconds. Right, what's the difference? Okay, first of all, velocity, if you recall, is speed and direction. So it contains two information. Now how are we going to put in the direction here on the graph? Right, just remember that for movement along a straight line, we choose one direction to be positive. So I've already, in the previous example, decided to choose my right side to be positive and the left side negative. So in this case, if I now plot the graph of the velocity, Okay, again, right, for the first second I would have walked 1 meter, so the speed is 1 meters per second. But what about the direction? It would be positive, so it would be plus 1 meter per second. So the plus here tells me the direction. So that's what happens in the first second. That's the time. That's the velocity with the positive sign. So okay, fine. And after another second, I've walked by the same distance. So it's still 1 meter per second, and that's just going to keep going at the same velocity all the way until the 10th second. Now that's looking exactly the same as that, and you might think, right, okay, that's really boring now. Okay, right, but what happens? What happens on the 11th second? Now on the 11th second, I decided to turn around. Okay, I decided to turn around and look for some trees. Maybe there's some trees down here, and some flowers. So I decided to turn back. Now if I decide to turn back, what is my velocity now? Right, my velocity, okay, my speed is 1 meters per second, of course, but my velocity I would need to add the sign to it because it's now changed that direction. So my velocity should be negative 1 meters per second. Okay, so let me put that in. So I should go to -1 for my velocity. So my point at the 11th second should be down here. No, so and now you see that it's starting to look different. What about the 12th second, 3rd second, and so on? 12th, 13th, and so on until the 20th second. I just kept going, you know, in the same negative direction at the same speed. So I'm going to get -1 meters per second, and so on all the way until the 20th second. So therefore, my graph after I've turned back would be here, would be below the time axis. It would be negative. So here's what my graph would look like. It looks like this. There's a line there, then it goes down here, and then there's another line there. So it's a step, and it's clearly completely different from this graph, which is just a line. So now that's something different.